Hi guys, welcome to today's video. We are going to go through some titration calculation question today. If you are wanting to, with the practical component, obviously I can't help with that, through YouTube. But I did record a, when I did the demonstration with my class last year, that's up on my channel if you want to have a look at that, the practical component. So with the change of this particular standard, the report writing is kind of the focus. I'm sure your teacher can help you with some template regarding the report, but it's mainly the calculation and the practical component people find a bit tricky. So today I'm aiming to help you out with some of the titration calculation questions. Okay, so let's just go through a few of the calculations on my screen. So you're more than welcome to pause the video at any time to give it a go yourself, but these are just some questions that my class did today, so I thought I'll put it online and they can obviously listen to this as well. So we're going to do this in blue pen. So let's have a look at this. Now, one key part with the titration is that you need to understand that all the numbers that we provide you, you need to use, and you need to use them once. Okay, so and it's often the most confusing part of titration is you don't know which numbers for what. Like you get two volumes, you get one concentration, and then I've seen plenty of people using the volume incorrectly or use the same volume twice when they're supposed to use it once and then use the other volume for the other solution. It's just, a lot of silly mistakes here and there. And even with my year 12s this year, I even told them in class, and like they are the bunch that probably made the most random mistakes I've ever seen in my dozens of years of teaching. They just, oh god, it's just hilarious to see, but not hilarious to do when you're in the internal, but from a fun perspective, it was quite interesting to see what kind of mistakes they make. All right, so let's have a look at the question. So we having HCl 0.235 moles per liter HCl, so that's in the burette, and then we titrating into 25 mils of unknown concentration of Na2CO3. So what you could do, you can make a note of all these stuff. You can do like HCl, you can make a note, the concentration is 0.235, and then the volume is from the burette. So if it's from the burette, that's a really long, tall instrument that we use. So this is going to be your titer. Okay, now for your Na2CO3, this is going to be your 25 mils of from the pipette, and then the concentration, so this is the volume, the concentration we don't know, so we actually want to figure that out. Okay, so this is normally the type of questions you get, very standard question. So first of all, you need to figure out the titer, so you use final minus initial. This is 18.60, this is 18.50, this is 18.35, and this is 18.55. Now, one really key thing, guys, is that what you need to make sure to do is to make sure that your titer is rounded to 2 dp. So if you look at all of the numbers that we've given you in the table, you can see that all of them are ending in 2 decimal places, because the smallest scale that you can visually see from a on the burette measurements on the scale is 0.05. It's either you got the scale over here, then your meniscus is either on the line, so that's 0.00, whatever that is, or it's something something 0 actually, and then always in between, and that's like 0.05. So it's either the final number should be a 5 or 0. It really can't be anything else because you can't physically see them. Okay, so just reminder that you can't just use all the titers we have. You actually need to use the concordant titers, which is going to be the 3 titers that are within 0.2 mils of each other, which is that one, that one, that one. Okay, so those are the titers we're going to use, and then that's why I say select the appropriate titers which you have and calculate the average titer. So we can do, so it's these 3 add together and then divide by 3. Okay, so I mean, if you're a mathematician, you can see it straight away that the average is just going to be 18.55. Now for here, the 18.55, make sure you round it to 2 dp. Now for all of the other calculations that we do in chemistry level 2 and level 3, you always round to 3 SF. But 2 dp is the way we go with the titer here. the reasoning I explained just now, because all of the titers in the tables are into dp. And then once you got this to dp, because this is in mils, we want to convert this to liters. So make sure, and if you one of those people that tend to make mistakes, just put 18.55 divided by 1,000 in your calculator, and then just copy the number down, which is 0.01855 liters. And then here you may go, all right, so why don't you round that to 3 ACF here? Well, this is simply a unit conversion. I'm more interested in converting the mils to the liters, so you don't actually round. You keep all of the 4 numbers that you have from the previous well, before the conversion. So you keep all the numbers here. Now, if you did need to round that anywhere, for this particular question, it doesn't really apply here yet. But you keep the entirety of your numbers in your calculation, which we'll talk about in a sec. Okay, so we know this is the titer. Now, this is where you get some people get confused. Like, remember, if this is a titer, the titer you get from the burette, and what was in the burette? HCl. So that means we know the volume of HCl, because that's 18.55 mils that was in the burette. So we can actually, we know C, we know V, we can actually calculate the mole. So that's going to be 0.235 moles per liter times 0.01, I forgot the 0.018 0.01855 liters, and that's going to give me 4.36 times 10 to the power of -3 moles. Now, if where's my calculator? So if you actually do this calculation, I'm just going to do it really quickly. If you do this calculation on your calculator, which I strongly recommend you to do, you will actually, on your calculator, it says 4.35925 -3. So what this means is 4.35925 times 10 to the power of -3. Okay, so that's what that E means, exponential. Okay, now you need to round in 3 SF. So you look at the first non-zero number, 1, 2, 3. Here you round because it's a 9, hence it's a 4.36 times 10 to the power -3. However, on paper you round, but when you're doing the following the calculation that we're going to do next, you are going to use the entirety of the number that we just written down here. You need to use this to do our calculation, which we need to do over here. You can't use 4.36 times 10 to the power -3 because that is a rounded number. And in chemistry, because this topic is all about precision, if you're losing, that's why we include every number, every digit, because if you lose a digit, you are potentially changing the concentration by 0.01 or 0.05. It can be a big change. So you really do need to make sure that you understand what we're doing here, and this applies to all of your other calculations in chemistry as well. Level 2, level 3, all of them. You never delete the number from your calculator. You are going to use the number function to continue the calculation. Okay, so over here we need to calculate the Na2CO3 mole. Now this is where we need to go back to the equation, which is right here. Now remember, we figured out the moles of HCl, so we need to look at these two. We need to look at these two here. You can see the HCl mole is twice as big as the Na2CO3 mole, shown by the coefficient in front. So that means your HCl mole, the moles of HCl is twice as many as the Na2CO3. It's doubles. So if I know the HCl mole, then I simply just divide it by 2. Use this number divided by 2 to give me, now because the ratio is 1 to 2, I'm just going to, on paper, I'm going to do 4.36 times 10 to the power of -3 divided by 2, but actually I'm going to use this whole thing divided by 2 to give me 2.18 times 10 to the power of -3 moles. Okay, now again, this number is rounded. You need to crunch those numbers in your calculator and use the entire number in your calculation. Now once we've done that, that is the moles. we actually need to calculate the concentration. How do we calculate the concentration? N equals CV. That means C equals the moles divided by the volume. So the mole is right here. The volume, if you remember from earlier, is 25 mils. And this is where people make mistakes. They're gonna, some of them reuse the titer again. They use that 18.55 mils again. You know, you can't use the same number twice. It's obviously wrong. You can't do that. You get given two volumes, you use them, you make sure you use them, you look at the chemicals you're dealing with, write them down, and write down those numbers that you've been provided from the question to do the calculation. So this is going to be 2.18 times 10 to the power negative 3 divided by 0.025, and that's going to give us 0.0872 moles per liter, which is a unit for concentration. Okay, again, this is rounded to 3 significant figures. All right, so let's come back here. Next one, if the solution is diluted 20 times, so that means this solution is 20 times diluted. So to find the original, you just use this number times 20 to give you the original, which is 1.7 moles per liter. Again, you do not actually do this calculation on paper. You use whatever this whole number is. It could be 8719 blah blah blah, whatever those numbers are. You use the entirety times by 20 to give you 1.74 moles per liter. And when it comes down to here, actually you need the molar mass. The molar mass of Na2CO3 from memory is it's 108. Let me just add that up really quick. 106, so the molar mass is 106 grams per mole. Okay, so this is a last conversion. So the mass concentration is measured in grams per liter. The mole concentration, normally the concentration is measured in moles per liter, but not everyone does chemistry. If you tell them the concentration of something is moles per liter, they probably don't understand what that meant. So what we do is that we convert that to grams per liter, because everyone understands in a liter there's some certain number of grams, and that makes more sense. And how you want to do that is you want to use your moles per liter, whatever your moles per liter, multiply by the molar mass, and that will give you the unit in grams per liter. So in this case, I'm just going to use 1.74 times 106, and that's going to give us 185 grams per liter. Okay, now make sure you actually round that number correctly. This is 3 significant figures. If you wrote it at, like, say, I think the answer was 184.7 or something, then that's wrong, because that's not rounded to 3 significant figures. So you need to get this into, get into the habit of writing 3SF. It's just a general rule that we have with rounding, 3 significant figures, unless it is the titer, which we use 2 dp, because the measurements of the burette measures 2 dp. Okay, so question number 2. So this one here, let's just do this really quickly. We can highlight some of the key things here. So 25 mil aliquots of H2SO4. So that means this was in the pipette. It even says here pipette by a standard solution of NaOH. So we know the concentration of NaOH from the burette. So that means this thing was in. We need the titer. So this titer that we're doing here, this titer we're calculating, is the titer for NaOH. So we can find out we know the NaOH concentration, and we know the volume from the titer. Okay, so which we can do here. This is going to be 13.20. This is 12.80, 12.85, 12.75. All right, so I pick some nice numbers. So the average titer again, so these 3 numbers add up divided by 3, so it's just going to be 12.80 mils, which is going to be 0.01280 liters, because I'm keeping all the 4 digits, transferring them across. Okay, so I know the volume now, I know the volume, I know the concentration, and now I can figure out the mole of the sodium hydroxide. And that is always the case. You always know the concentration of the standard solution, because you can dissolve X grams of stuff into a certain mils of or liters of water, convert that grams to moles and use that moles divided by the mils and then divided by the liters, and you got your moles per liter, you got your solution. All right, so let's look at the moles. So this is N equals CV, so this is just going to be 0.01280 times 0.462, and that will give us 5.94 times 10 to the power of -3 moles per liter. Again, you should definitely, you don't just sit there and watch me do this. I always tell those people in my class, actually use the numbers use a calculator, crunch those numbers in, and because while you're doing that, you're practicing this, and that means you have a lower chance of making the silly mistake in the internal. All right, let's look at the equation. So once we got the mole, we need to look at the other mole by looking at the mole ratio. So again, you can see this one's 2, this one's 1 mole to 2 moles. So what do we know? We know the sodium hydroxide moles, so we know that the sodium hydroxide is twice as big. So to go from that to that, I need to divide it by 2. So that's another divided by 2. So the mole, it's just this number divided by 2. And that will give us 2.97 times 10 to the power -3 moles per liter. All right, now we need to calculate the concentration. So we know the mole. Oh, sorry, made a mistake. This is the mole, not moles per liter. We know the mole. We know the volume. The volume is 25 mils aliquots. You can revert back to 20 seconds, you can see that 25 moles. So we know the mole, so C equals N divided by V, so it's 2.97 times 10 to the power -3 divided by 0.025 liters, and that will give us 0.119 moles per liter. And then from there, we calculate the molar concentration in the original solution, which is diluted 10 times, so that means the diluted stuff is 0.119. That means the original is 10 times stronger. That's going to give us 1.19 moles per liter. And to calculate the grams per mole, so again, we need the molar mass. This will be provided to you, so don't worry, I just didn't do it here. This is going to be 98 grams per mole. So you just use 1.19 times 98 to give you 116 grams per liter. Okay, so these are some of the calculations. Well, not the only, the majority of the calculations you need to be able to do. You do need to be able to do the standard solution calculation, but I feel that is really, really easy. Like if you're getting this, you're gonna get the other one. Just watch out for the key thing that you need to look out for is rounding. If you're rounding, like say, if you're not rounding them correctly, if you're not putting the correct unit, you're not going to get excellence. If you are not using the entirety of the numbers in your calculation, like say if you're just rounding them and then you decided to use a rounded number to do the calculation, your final answer will be different to what your teachers will get. And then you like say for example, I'm just making example, like say 116. If I actually, does this actually work? Yeah, like say for example, if you actually do this on your calculator, 1.19 times 98 is actually 116.62. So that should actually round to 117. Okay, so you probably, if you were someone here that went, all right, I'm just going to use what I've written on the paper, and then you went with that, and the final answer is that, then you can kiss your excellence goodbye, because you have not shown correct understanding of calculation in this particular standard. Okay, so it's it just takes a lot of practice. Make sure you get plenty from your teacher, or you can, the calculation, the reason I don't do this very often, because the calculation I feel is very standard. You don't really get anything out of the ordinary, since the focus has shifted towards the investigation side of things. The calculations, it's an important part of the investigation process, compared to when it used to be like majority calculation and practical work. So the emphasis has shifted, so there's not many calculation variation out there. Okay, so hopefully this video has helped you. Subscribe and leave a like if you haven't, yeah, I'll see you guys next time. Bye bye.